The Leave Plan of Room experts has found that utilizing our new $10 billion toy, it will be seemingly forever before that try changes into a reality. In the event that it goes as organized, the excursion to Proxima B will require close to 20 years. So, reasonably, it will be an incredibly long time frame before we can affirm if there is, without a doubt, life on that planet. The deep-rooted solicitation of whether we are truly alone in this universe continues. The James Webb Telescope has found some startlingly human things far away from Earth that lead us closer to the response. Our excursion for life beyond us has been wild all through each human improvement, so much that we have an extensive number of media creating theories concerning this matter. Our wonder concerning our place and sadness in the universe has been unsurprising, as though it is pervaded within us to constantly look for a buddy, regardless of how untouchable-like we may be. We may get continuously nearer to the responses we genuinely need. However, are they, as a matter of fact, the responses we are searching for, or are they significantly more surprising? Join us as we research the most recent exposures in the spaces of universes and planets on the trip to track down something we, in all probability, will not be ready to take note of. Lights very far away, investigators have found what could be the most huge openness in history. Back in 2021, when the James Webb Space Telescope was planned to launch, a very fascinating speculative solicitation was raised about the constraints of our development. The solicitation was whether, later on, our telescopes could recognize counterfeit light on another planet, for instance Proxima B, the nearest exoplanet to Earth. Proxima B, around 4.25 light-years away, was recognized to be impeccably locked with an incredibly intense day-side and night-side, like our Moon. A theoretical creative advancement on Proxima B could move power and energy from the day side to the night side utilizing photovoltaic cells that produce power from starlight. In a paper with Manasvi Lingam as one of the inspectors, it was shown that the enormous joining of the day-side sunlight-based chargers could be perceived with future telescopes. Since JWST was further developed, it would permit us to expand our mission for counterfeit lights to substantial exoplanets like Proxima B. Now, the fact that the James Webb Space Telescope makes it conceivable, in 2024 it did precisely that. Utilizing its higher responsiveness and more perceptible scope of limits, the JWST could have found the lights we were looking for and perhaps flung us into another gigantic flood of human progress. All things considered, let us dive into the universe of planets and exoplanets to figure out how this was even conceivable. James Webb's mission explores Proxima B's secrets. Since the beginning of time, humans have considered the probability of the universe, what we are, where we come from, and where we go. These are commonplace yet exceptionally complex questions that humankind has tried to answer since we gained awareness. Now, in the era of excellent technological advancement, one wonders if we are any closer to answering these questions. If you were to ask a philosopher, he might say we are still at level 0 of understanding ourselves in the universe. However, ask an astronomer the same thing, and watch him bounce with excitement as he rushes to tell you about the latest discoveries humans have made about the universe using their sharp instruments. These contraptions, though not given much thought by the general public, are clearly a sign of human progress itself. We now have the world readily available, and it is time we push forward and get the universe within reach as well. One such technique for doing that has been considered by experts and space researchers. Through this development, we set up a particular plan of progression that is already responsible for the recent revelation of what might be light on a distant planet light-years away. Yes, we're discussing the James Webb Space Telescope. The James Webb Space Telescope is the creation envisioned out of the traditions of human missions into space to answer a few age-old questions. Are we alone? Who's out there? Where do we start and where do we end? This infrared astronomy contraption has recently started addressing these questions. To some extent, you might find yourself asking, what is Proxima B? Proxima Centauri B, or simply Proxima B, is part of a system known as Alpha Centauri. It is a super-Earth exoplanet and orbits an M-type star. At any rate, super-Earths might intrigue you. Don't worry. This text will guide you through all your burning questions. Super-Earths are a class of planets that are more massive than Earth but lighter than ice giants like Neptune and Uranus. They are unique. They can be composed of gas, rock, or even a combination of both. Their sizes can vary from twice the size of Earth to several times its mass. They truly put the super in super-Earth. Concerning Proxima B, it is a super-Earth and an exoplanet, meaning it is a planet that orbits outside our solar system. The first possible evidence of an exoplanet was found as early as 1917, though it stirred little interest or confirmation. However, in 1992, the first confirmed discovery occurred, which left researchers amazed. Another exoplanet, first perceived in 1988, was admitted in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Out of these, 896 systems have more than one planet. These remarkable discoveries are circling an M-type star. To understand an M-type star, you need to understand the concept of a red dwarf. A red dwarf is the smallest type of star in the main sequence, hence the name. In the neighboring vicinity of the Sun, red dwarfs are by far the most commonly found type of star in the Milky Way. They have extremely low luminosity, and since luminosity is one of our primary tools for planet detection and various types of inference, red dwarfs are not particularly easy to observe. These faint stars have variable definitions and names depending on their temperatures and sizes. For instance, M dwarfs or M-type sequence stars emit a maximum temperature of about 3000 K, thus earning their classification. Returning to Proxima B, its mass is known to be nearly equivalent to 1.07 Earths. Interestingly, it requires just 11.2 days to complete one orbit of its star, compared to our 365.25 days. You can imagine the size of the star Proxima B is orbiting. Proxima B orbits its star at a distance of about 0.05 astronomical units, significantly closer than Earth's distance from the Sun. Despite this proximity, the star's low luminosity results in Proxima B receiving less total energy than Earth does from the Sun. The star emits most of its energy as infrared radiation, with over 85% of its emitted energy in this spectrum. The discovery of Proxima B was announced back in 2016. You might wonder why Proxima B, among countless stars, planets, and galaxies, garners such significant interest. There are several compelling reasons for this. First and foremost, Proxima B is the closest known exoplanet to our solar system. At just 4.25 light-years away, it is a tantalizingly reachable target for exploration. While this distance is vast by human standards, it is a mere blip in the grand scheme of the universe. This proximity places Proxima B high on the priority list for study. Additionally, Proxima B is part of the Alpha Centauri triple star system, which includes Proxima Centauri, Alpha Centauri A, and Alpha Centauri B. Despite Proxima Centauri's faint glow, the system as a whole appears as one of the brightest celestial objects in the night sky. The most intriguing aspect of Proxima B, however, is its potential habitability. It resides within its star's habitable zone, the region where conditions might allow liquid water to exist on the planet's surface, a key ingredient for life as we know it. This possibility has fueled intense interest and research efforts to understand the planet's environment and potential for hosting life. This is where the James Webb Space Telescope, JWST, comes into play. Its advanced capabilities are perfectly suited for studying exoplanets like Proxima B. The JWST's 4 primary scientific objectives include searching for light from the first stars and galaxies that formed after the Big Bang, studying the formation and evolution of galaxies, investigating the formation of stars and planetary systems, exploring planetary systems and the origins of life. By continuing its observations of Proxima B, the JWST brings us closer to achieving these goals. Its infrared capabilities allow it to detect faint signals from distant planets, providing valuable insights into their atmospheres, compositions, and potential for life. The search for extraterrestrial life has always been a cornerstone of humanity's curiosity. From ancient myths to modern science fiction, the question of whether we are alone in the universe has captivated our imagination. This relentless pursuit has led to the development of projects like the Search for Extraterrestrial Intelligence, SETI. SETI represents humanity's collective effort to detect signs of intelligent life beyond Earth. The program monitors electromagnetic signals from space, searching for patterns that might indicate the presence of advanced civilizations. In 1977, SETI detected a signal known as the WOW signal. This brief, unexplained radio burst was so remarkable that the astronomer who discovered it scribbled WOW in the margins of the data printout. Although the signal has never been conclusively explained or replicated, it remains one of the most intriguing events in the search for extraterrestrial intelligence. Today, SETI's efforts have expanded beyond radio signals. Researchers now search for technomarkers, evidence of advanced technology that might include artificial light, industrial pollution, or large-scale energy usage. The JWST's ability to detect faint infrared signals makes it an invaluable tool for identifying such markers. The recent discovery of potential artificial lights on Proxima B's dark side is a groundbreaking development. If confirmed, it could signify the presence of an advanced civilization capable of harnessing energy and illuminating its environment. This discovery raises profound questions. Are we truly alone in the universe? If intelligent life exists on Proxima B, what does it look like? How does it communicate? What can we learn from it? The implications of such a discovery are staggering. It would challenge our understanding of life, intelligence, and our place in the cosmos. It would also open new avenues for exploration and collaboration, uniting humanity in a shared quest to connect with our cosmic neighbors. As we continue to probe the mysteries of Proxima B and other distant worlds, we edge closer to answering one of humanity's oldest questions. The journey is far from over, but with tools like the James Webb Space Telescope and the unwavering determination of scientists and researchers, the future of space exploration holds limitless possibilities.